in the previous part, you have learned everything regarding the basics and principles of testing, and you have also seen how to write unit tests, which we are actually looking at right now on the screen. And you have also learned how to do test-driven development, because we have written tests first and only then implemented the functionality, which in our case was in the news change notifier. So continuing with this app, which is currently running here on this simulator, we are now going to do widget tests and also integration tests. Hello, welcome to Reso Coder, where you're getting prepared for real app development so that you will get freelance clients or a job and be confident about the apps you build. So subscribe and hit the bell to join us on our quest for becoming in-demand Flutter developers. I have explained all the details of what a unit, widget, and integration test is and how many you should write in the last part. So if anything is unclear, please just refer to the beginning of the first part of this two-part series. Basically, while unit tests only test the logic, right? Because we are testing the news change notifier, and the only thing we can test here is if isLoading is set to true at the correct time, if the articles are really being loaded from the news service, and so on. That's all we can do with a unit test testing a news change notifier, and that's exactly what we have done here. But when it comes to widget and integration tests, what we are going to be testing is the actual user interface. If everything is visible in the user interface, if after tapping on, for example, this list style, we are going to be taken to the article page where the whole article content is displayed. These are the kind of things which are going to be tested with widget and integration tests. Now, we are going to start with widget tests, and only afterwards we are going to perform integration testing. The basic difference between widget and integration tests is that widget tests test only a single widget. They can know, let's say, more details about what's being tested, although in this app we're not going to see as many differences between widget and integration tests as in some huge apps, because, well, this app is of course kept simple so that we can just focus on tests. But in some huge apps, widget tests would appear simpler than integration tests, because integration tests, as is apparent from their name, test the integration of multiple components, multiple widgets together. So by definition, they need to be a bit more difficult, of course. For example, in this app, the integration test we are going to write is going to navigate to another page by tapping on a list style, right? And it's going to check if everything fits, if everything is displayed correctly. So this is going to be for the integration test, whereas the widget test, which should be simpler, is not going to go to another page at all. It's just going to remain here in the news page, and it's just going to check things inside of the news page, but it's not going to navigate away, right? So widget test will be simpler than the integration test. Now, before actually writing the widget test, another striking difference between widget and integration tests is that widget tests just run in a simulated user interface. You don't actually see it. Nothing will be displayed inside an emulator, and therefore widget tests are very quick to write. But of course they're not as precise because everything is just simulated. You, for example, cannot test performance of an app with a widget tests, but you can test performance of an app with an integration test. Why? Because as opposed to widget tests, integration tests actually show up on a simulator, and when we run our integration test, you're actually going to be able to see this precise app being automatically tapped on, navigated. We're not going to perform the clicks ourselves. It's going to be handled by the actual integration test, but everything will be visible even to our very own eyes. That's not the case with the widget test. All right, with this out of the way, let's now write our widget tests. We are going to create a new file under the test folder, much like for a unit test. Let's call it the news page test. .dart. Also, make sure to check out the link in the video description where you will get the starter and finish project for this tutorial. And also over there, you're going to have the code snippets, which I will mention somewhere throughout this tutorial. We're going to have a code snippet for a widget test, much like we have a code snippet for the AAA test, as we call it, from the previous tutorial. So make sure to go and click on that link so that you will get everything you need. And this is where we are going to write our test. We can actually use the tscaffold snippet, which you should have already available from the previous part. But as opposed to unit tests, we are actually not going to need a system under test because we are not testing a class, we are testing something which is within a widget tree. So while widget tests are very similar to unit tests, they're not exactly the same. So for example, we do not need this SUT system under test thing over here, this object. However, what we are going to need is our trusty mock news service, much like we have it over here in the news change notifier test, which is a unit test, because even when it comes to widget tests or integration tests, we cannot be working with real network data because it's unreliable, the internet might be down, and so on and so forth, as I've explained in the previous part. The same things apply to widget tests and integration tests as apply to unit tests in this regard of mocking and so on. So we need to use our mock news service inside of our news page test 2. Now we are copying code all over the place, and you might say that this is a code duplication, and you would be right, but in this case actually I much prefer to have code duplicated across test files than to extract it somewhere, unless it's just a lot of code. But these kind of one-liners for mocks, I would just keep them inside of their test files directly where these mocks are used, just so that we do not confuse ourselves. The same goes for all the other code associated with having a mock here. So if we go to news change notifier test, we of course need to have a variable for the mock news service and also set it up. So let's copy this thing, right? Boom. Actually, we can overwrite this setup call. And of course, we are not going to have any system under test, so let's delete this line. All right, so now we are going to have a mock news service object available here. So let's create the first actual widget test, shall we? Unlike with the unit tests, where we already have this AAA test snippet created, and we just basically create a test call, with widget tests, we need to use another kind of a call, which is test widgets. So test widgets, right here, boom. And test widgets is very similar to just the test function, but it actually accepts a widget tester as a parameter here for the callback function. As I've said multiple times now, widget tests and therefore also integration tests operate, of course, on the widget tree, and we need to perform some actions on the widget tree, like tap something, drag something, or even rebuild the widget tree, because in tests the widget tree does not get rebuilt automatically as when the app is running, right? Here, when I press somewhere, I get navigated to another page, and the widget tree just rebuilds itself. But this is not the case when you are running tests. You actually need to tell the widget tree from a test to rebuild itself at this exact point of time. It doesn't rebuild itself automatically inside tests, right? So this is why we have this widget tester. We just use it for all kinds of things when it comes to the widget tree inside of tests. So what is the first test going to test? Well, let's start with something simple and something which is static on the news page, right? Because we always start from the simplest things. At least that's how I like to do it, because once you have your simple tests covered, which you just know what to test right off the bat, then you can start thinking about the more complicated tests. So what is something static that doesn't really need any data here? Well, that's the news title. This news title should be visible inside of the news page. So let's test that the title is correctly displayed. So this news text should be here. So this test will test for title is displayed. And what are we going to do here? We're not going to write the correct code right from the start. I will walk you through sort of a thought process of what you might want to do, and this way you will see why widget tests are written the way they are. So let's just start with something completely simple, which is just to put an expectation here. So expect, and we expect to see or find the text news somewhere here on the page. So how to translate it into a widget test code? Well, we expect to find, so let's just say find, pretty simple. And we can find a lot of things, or we can search by things, by a lot of things. So by icon, by key, by type. But in this case, we actually just want to find a text news, right? And we want to ensure that there is one widget that is found. So we say finds, and then we can say finds nothing, finds one widget, finds widgets, or finds a number of widgets. In our case, we just want to find one widget. We want to ensure that there is one title news somewhere on the news page, right? And actually, even without running this test, there is some sort of an issue. I've just said that we want to ensure that this news text is found on the news page, but nowhere in this whole file are we indicating that we are actually testing the news page widget. It's nowhere here. So we somehow need to make sure that we are actually testing the news page widget, right? Much like we have a system under test class, which we are testing within the unit tests, we need to have something similar for the widget tests. But it's not going to be just with a simple late field called SUT. It's going to be quite different. Since we are testing the news page, instead of this test, we need to sort of create and build the news page into this invisible UI, which is being tested, but which we do not see while it's being tested. And we can do so by using this widget tester and saying tester dot pump widget. Pump widget will create this widget so that it can be used within the test. This is something similar to when you launch the app on your device, the main method gets called and the widget tree gets created. Basically, a similar thing is happening here when we call pump widget. And which widget do we want to pump? Well, let's just say that for now we want to pump the news page. Right? Let's now try and run this test. We're not going to see anything on the emulator because this is just a widget test. and it fails. So let's actually see why it failed. So we are actually going to probably see it much better if I just open up the debug console here. All right. Whoa, so there's a lot of things going on. No media query widget ancestor found. Scaffold widgets require a media query widget ancestor. All right, so even without going much further, we can see that there is no media query found. Also, there is no provider found. So what's going on? Well, if we take a look at our news page implementation, we see that indeed we are trying to find the news change notifier from the provider, which should be somewhere above this widget news page in the widget tree, and this is not possible. The same goes for the media query. We are trying to find the media query, or more exactly, the scaffold is trying to find the media query, but it's nowhere above in the widget tree. So what's going on? Well, the problem is that when the app is running on a device like usual, not inside of a test, we are launching the app using main.dart. And what's happening inside main.dart? Well, we have this my app widget, which wraps the news page inside the change notifier provider, which needs to be here for this news page to be even able to run properly without crashing. And also we have this material app here, which ensures that all the proper widgets are provided down. So this includes the media query, for example, among many other things, of course, which material app ensures that are there for the app to use. So now you might think that inside of our news page test, we just want to pump the my app widget instead of the news page widget, right? Because pumping my app would ensure that everything is wrapped inside of the material app and also inside of the change notifier provider. Well, that's not exactly true. We do not actually want to do that, because if we go to main.dart, we see that inside my app, we are always providing a news change notifier with the news service, which actually, let's say, communicates with the server. In our case, this is a fake communication with the server, but nevertheless, the articles provided by this news service are basically random, generated by this lorem ipsum generator. So we definitely do not want to have this kind of a news service being used from within our widget tests. Therefore, we just cannot directly create a my app instance within a widget test. But we still want to have this kind of a structure for our widget test widget. So what we are going to do is that we are actually going to copy the contents of this build method, copy them, go to our news page test, and let's create below this setup method a widget returning function, create widget under test. So much like we have a system under test for unit tests, we have a widget under test for widget tests. Very similar concepts, just quite differently implemented, let's say. And let's paste what we have in the clipboard over here. And we will need to import a bunch of things like Flutter material, provider, news change notifier, boom. All right. And now we can swap this news service for the mock news service instance, which we can actually control, much like we can arrange stuff in unit tests, like arrange service returns 3 articles. We can do the same things within widget tests. Let's actually copy this method from the unit tests, arrange new service returns 3 articles, and paste it here. Also, we'll need to get the articles from service list over here. Let's copy that too and paste it. All right, let's import article. And now we can say in the test widgets that we want to pump the widget that is returned from create widget under test, just like that. However, this test will still not work, it will just crash. And the reason is simple, you will actually see it once I run it. The reason is that we are not arranging the mock new service in any shape or form. So therefore, we basically return null from a function which should return the future list article from this mock new service. So what we need to do, since we have the arrange function already here copied from the unit test, let's just call this arrange new service returns 3 articles at the beginning of this widget test, and now run it, and everything is going to work perfectly fine. Or actually, it will not function properly. Why is that? Well, this pump widget is a call which returns a future, and it actually needs to always be awaited within tests, so make sure you never forget about that. And now at last we can run this widget test and it's going to pass. All right, it passes. So what should we test next once we have tested that the static parts of the UI are indeed present there? So we probably want to test the list view, but we must remember that this is not only about the list view. This is also about the loading indicator, so we should test if while the articles are being loaded from the server, that the loading or circular progress indicator is being shown, as it is if I hard restart the app, right? This is what should be here, the loading indicator. So let's test for that. We're going to create another test widgets, or actually I have a code snippet for you which will be in the lesson notes, so check it out, called W test, which is just a simple shorthand for creating a test widgets. And this test is going to test that loading indicator is displayed while waiting for articles. So let's first handle this waiting for articles part. This is what we will need to arrange using our mock news service, because that's where we can actually introduce some sort of a wait time, right? And if we take a look at the arrange function we have currently here, this arrange news service returns 3 articles. Here, there is really no waiting involved, really, because yes, we do use then answer and get articles returns a future, but this future gets resolved instantly because there is no delay. We just return readily available list wrapped inside a future, but it's really not going to take any extra time. So we actually need to introduce some sort of a real delay into our code so that we can test the circular progress indicator properly. Therefore, let's create another arrange function, which we are actually going to create by copying the previous one, but this is going to be called the same. So arrange news service returns 3 articles, but after 2-second wait. We're going to ensure that this 2-second wait actually happens by firstly converting this then answer callback inside of it into a block body method, and then within this body we're going to await future dot delayed, and we're going to wait for const duration, well, seconds 2. And now we can call this arrange function from the beginning of the test we are writing currently for the circular progress indicator. Then we can, of course, pump the widget under test, like that, much like in the previous test. And now you might think that it's enough to just call expect, and we expect to find by type, because we actually know the type of the widget we are trying to find, which is the circular progress indicator, of course. And the matcher will be finds one widget, right? So you might think this is enough, and it appears to be enough, but as you might imagine, the truth is quite different. So when we try to run this test is actually going to fail. So why does it fail? Let's check the description of this. So basically expected exactly one matching node in the widget tree, but it was not found. So this circular progress indicator is nowhere to be found. Why is that? Well, we do arrange the 3 articles after 2-second wait, but we don't even give a chance for this news page consumer to run and to return this circular progress indicator here by checking if notifier.isLoading is true, because we don't even give time for the consumer to catch up with everything and for the provider to catch up with everything. It just happens so quickly. So the basic static UI is being displayed like only after calling pump widget over here, right? Much like we have seen in the previous test we have written. This has worked perfectly fine, no issues, the test has passed. But this applies only to the, let's say, static UI, like this news text, which is the title inside the app bar. But when it comes to something more dynamic, we need to give it a bit more time to just initialize and be displayed. So how can we do that? Well, let's go back to the news page test. And right after pumping the widget, let's not put the expectation here, but instead we are going to say await tester dot pump, and not pump widget, just pump this time. And pump forces a widget rebuild. So the build function inside of the widget is going to run. And also inside of this pump, we can provide a duration. So let's say that we are going to trigger a frame, so trigger the widget rebuild after 500 milliseconds, because since we are waiting for the 3 articles to be returned for 2 seconds, after 500 milliseconds, the circular progress indicator should still be spinning even after 1 second, even after 1.5 seconds, but after those 2 seconds, it should actually stop spinning and the list of articles should be displayed. But since we are now checking for the circular progress indicator, we're just going to wait for 0.5 seconds, which is 500 milliseconds, so that we can test for the indicator. So let's say const duration, milliseconds, 500. Awesome. So let's now try and run the test, and let's see what happens. It again fails. And this is interesting. But actually, if we take a look at the more visible output here, this time it did not fail because it could not find the circular progress indicator inside of the widget tree. This expectation has run just fine and it has passed. The test has failed because of pending timers of duration 2 seconds, which is the future delayed, which we have created in the arrange method, right? This is running for 2 seconds, and this timer is for 2 seconds, so these are the same things we are talking about, the timer and the future with the duration. And this is a problem. So what's actually happening here and how can we mitigate this issue? Without going into much detail about how tests work, tests actually create a fake async zone, let's call it a sandbox, so the features don't actually run in their true amount of time, right? So 2 seconds doesn't necessarily mean 2 seconds in a widget test. And this brings with itself a bunch of problems. Like, for example, if we still have a feature which is, well, running, it's still waiting for something, it's still in progress, we could say, and the test code finishes before this feature has been fully awaited, before it has finished, then we get this kind of an error. And why do we get it here? Well, because we have a feature which will exist for 2 seconds. We are delaying execution of the arrange method by 2 seconds, but we reach the end of this test code after just half a second, right? So it has 1.5 spare seconds for this to run. And this creates this issue. We can solve this by calling await tester.pump and settle this time. Pump and settle waits until there are no more rebuilds happening, like animations. And what is an animation in our case that is being shown in the UI? Well, this circular progress indicator which is being displayed is actually animated, right? It's spinning. So this counts as an animation. And therefore, if we await for tester.pump and settle, which means we await for until there are no more animations displayed on the screen, we're going to await for exactly the time while the circular progress indicator is being shown on the screen, right? Because it spins around. So while it's spinning, we're going to be waiting right here. And the test will not end yet because we are waiting at the last line. And then when the circular progress indicator disappears, this feature will be completed, so the test will also end. But by that point, the 2 seconds for which we need to wait have already passed, because the circular progress indicator will not disappear until, right here, these articles from service are actually returned from our mock. This means that the delayed feature has already passed. So that's why we can just say pump and settle, and this is going to solve our problem here. So let's run this test again, and it passed. Awesome. While we are here, let me also showcase that you can find widgets by more than just a type or by text, right? So for example, we can find widgets by icon, key, semantics label, tooltip, and actually finding widgets by key is very common, right? Because while you can have, it's not very usual, but you can have multiple circular progress indicators in one page, and that would be a problem because which one do you want to find, right? You actually will have only one widget with that particular key in a page at all times. So finding by key is very handy when there are multiple widgets of the same type. Of course, this usually doesn't happen with circular progress indicators, but if you are trying to find buttons or something like that, which is being tapped on by the user, then finding stuff by key comes very handy. So because of the fact that we need to find a widget by key, let's actually go to the news page, and we're going to add a key to the circular progress indicator. So let's just say key, which will be key, and let's just say progress dash indicator. And let's now just copy this key object and say that we want to find the widget by this precise key. Now let's run the test, and it's again going to pass. I just wanted to show you this finding widgets by key because it's very common in widget tests. And now that you know about all these kinds of intricacies of writing tests, or widget tests. Let's now create the last widget test in this file, which is going to be very simple because you already know a lot. So let's write w test, so test widgets, articles are displayed. And so first we of course want to arrange that new service returns 3 articles. Then again we want to call tester.pump widget like that, so that everything including the material app and of course the news page is created. Since we are again dealing with something which is not, let's say, statically displayed, we actually need time for the consumer provider to initialize and catch up with everything. Of course, besides just that, we also need for the init state inside the news page to actually run, right? Because it's here where we call get articles. So because of all these reasons, we again need to call tester or await tester dot pump. This time we don't actually need to introduce any duration into this pump call because we don't really care. We just need to trigger another rebuild and that's good enough. We don't really need to delay it by any duration because these 3 articles, of course, in this case are gonna be returned instantly as opposed to from the other arrange method, in which case they are delayed by 2 seconds, but they are not delayed in this arrange method, which we are using from our last test here. That's why we can call only pump without delay. And now what do we want to test for? Well, for each final article in articles from service, which are being returned from our mock, we expect to find text equal to the particular article from the loop dot title, and we expect to find, so finds one widget, and the same goes for the content of the article, right? So let's run it, and this test has passed, so everything worked. We can actually now run all of the tests by running the main method. Let's see if everything runs properly. Let's open up the debug console. Everything has run correctly, which is awesome. So now you know how to write widget tests, and this may feel already enough for this part of the tutorial, but actually when it comes to integration tests, you are not going to learn a lot of new things. They are really widget tests. Everything happens very much in the same way as inside widget tests. The syntax is the same. You still pump widget, you still use the tester, you still use the finder here to find, for example, by type or by key. Everything stays the same with integration tests. The only thing that changes is that they are actually run on an emulator or of course on a real device, as opposed to widget tests, which are just run on a simulated UI. So let's get right to it. We are going to create an integration test file, which is actually not going to be within the test folder, but rather we're going to create a brand new folder at the root of our project and call it integration test. And inside of this integration test folder, we are going to create a file called apptest.dart. It's called apptest because integration tests should test either the whole app, which is happening in our case because the app is very small and simple, or if you are working on a huge app, you might test individual parts that make sense together in a particular integration test. But you really never want to test a single widget or just a single component of an app from an integration test. It's not prohibited, you can of course do it, but Integration tests, because they are so expensive, they are really slow to run, they should be reserved for really just testing the app overall, testing the UI flow, testing what the user can do from a very user-based perspective, from a high level. Integration tests should be used very sparingly. You should definitely not have the same amount of integration tests as you have the amount of unit tests or widget tests, because that would really slow down your testing procedures. Integration tests, there should be few of them, they should be high quality, and that's it. Our app test will reuse a lot of code from the news page test, which was the integration test. So let's actually copy everything, including the imports, then the mock news service, the main method, setup, and everything until the arrange news service returns 3 articles. So let's copy everything like this and paste it into our app test. We just need to end the main method by a curly brace. And let's also copy then the create widget under test function right here. This, of course, is another horrible code duplication, but we're going to leave it like that for tutorial purposes. Usually, you're actually not going to have this like exact one-to-one code duplication between your widget and integration tests. But in this case, because the app is so simple, that's actually the case. You can, of course, extract test code, much like you do with your production code, so that you do not have any code duplication. You're free to do whatever you want if you feel like code duplication is something that bothers you in test code. But actually in test code, it's quite fine to have code duplication. It's not as bad as in production code, but of course this is truly over the top. I would definitely recommend you to play around with it and see what you can extract somewhere so that you don't have this much code duplicated. So we are writing an integration test, but truly we are going to write a W test using the code snippet. So that's test widgets. Exactly the same thing as with the widget tests. So what do we want to test here? We want to test the whole app, and basically the only thing which we can do in the whole app is that after tapping on a list tile, we are taken to the article page where the whole article is displayed. And that's really it. That's all the app does. Also, from the integration test, we do not need to test if the news title is displayed or if the articles in the list are displayed. No, this is already tested by the widget test, right? We are testing for this already, for the news title, for the loading indicator, for the articles to be displayed. And that's exactly how it should be, because widget tests are less expensive and faster to run. So they should test everything they can, and then the integration test should really be reserved for testing the integration of all the different pages, of all the different classes together, right? Much like we do here. So what do we want to test at last? We want to test that tapping on the first article, excerpt, opens the article page. Let's create a multi-line string here because we are running out of space, where the full article content is displayed. Boom. So tapping on the first article excerpt opens the article page where the full article content is displayed. What do we want to do within this test? Well, first, of course, we want to arrange the news service returns 3 articles, so we do actually have something to tap on. Then we want to await tester.pump widget. Much like in regular widget tests, we're going to create widget under test instead of this pump widget call. Then again, for everything to initialize, for the init state to run, we need to call await tester dot pump. This is again exactly the same as in a widget test. Then we want to tap the first article list style. Now, the easiest way we are going to be able to find the first article's list style is by finding the text within this list style and tapping on that, which in turn is going to, of course, tap on the list style too, since the text is within the list style, right? So we're going to say await tester dot tap, and we want to tap on something we find by text. So find text, and the text will be test1 content, which is what's returned from this article from service, right? Test1 content, that's gonna be in the list style as a subtitle. Then after tapping on this, we should actually be taken to another page, which is a process that takes some time and it's animated. So we want to wait until all of these animations finished, and you already know what we can use for waiting until all the animations are finished, and that's the pump and settle call. So let's call await tester dot pump and settle, just like that. And now once we are on the article page, let's just check that we are truly on the article page and no longer on the news page. So we're going to expect that find by type news page finds nothing, and article page, which we need to import, of course, this actually finds one widget. So this test or these expectations mean that we are no longer on the news page, but we are instead on the article page. And then also we want to have another expectation that we actually can find text test1, because that's the title of the first article we have here being returned from the news service, which we mock. So this finds one widget. Let's just copy this below, and test1 content should also find one widget, like that. And that's really it. It's as straightforward as that. It's exactly the same syntax as a regular widget test. And now once we click on run here and we have the iPhone 13 simulator running, you can also launch it on an Android simulator, no problem. So let's run this. It's launching, and when I open the simulator here, actually let me close this. Boom. So I've just closed the app which was running, which is actually from the preparation project, but now we should very soon see the actual test app running. So it's going to get installed on the device and everything will run automatically. As you can see, it takes a lot of time for this to be built and installed on the device. That's why you should reserve integration tests only for testing something very important and something high level. Definitely you should not have very many integration tests because of the slow speed of execution, because it actually needs to install a real app on the device. And here we go. The app is being installed. I'm not touching anything. I don't have the mouse here. I've moved it away. Boom. It has run, and we can see that it's successful. Everything happened automatically, right? And if we open up the console here, we can see that indeed everything has run correctly, and the Xcode build has taken 67 seconds, which is quite a lot. That's a lot of time. All right, anyway, so you just see why you should use integration tests sparingly. Now, of course, if you have multiple integration tests within one file, within one main method, all of them will run only after one time of the app actually being built. So It's not like for every test widgets, you're going to wait for 67 seconds all the time. Of course, it gets faster once the initial app is built and installed on the device. Then those tests get faster, but still they're quite slow compared to unit and even widget tests. And that is it for this two-part series about testing in Flutter. If you don't want to miss more tutorials like this, be sure to subscribe to this channel and also join the notification squad by hitting the bell button to make sure you grow your Flutter skills, because here on ResoCoder, I am determined to provide you with the best tutorials and resources so that you will become an in-demand Flutter developer. If this video helped you, give it a like and also share it with other people who are going to benefit from it too. Leave a comment if you have anything to say, and see you in the next video.